Okay, so this is problem 26 from chapter 4. And what this problem says is the Icaros spacecraft launched in 2010 was designed to test the feasibility of solar sails for spacecraft propulsion. These large ultralight sails are pushed on by the force of light from the sun, so the spacecraft doesn't need to carry any fuel. The force on Icaros' sails was measured to be 1.12 micronewtons. If this were the only force acting on the 290 kilogram spacecraft, by how much would its speed increase after 6 months of flight? Okay, so we know that force equals mass times acceleration, and so what we wanted to find first was the acceleration. And so we just manipulated that equation, and so we get acceleration equals force over mass, and so that's 0.00112 newtons, because again it was 1.12 micronewtons, and then that was divided by 290 kilograms, which is the mass, and so then what we got was 3.86 times 10 to the negative 6 meters per second squared. Okay, so then we wanted to use the equation A equals delta V over delta T, because we had the constant acceleration, but we were given a delta T, but we need to convert that to something that we can actually use, which is seconds, and so we had to go from 6 months all the way to seconds, and so that's what you are seeing right here with that dimensional analysis, and so delta T ended up being 1.555 times 10 to the 7 seconds, and so delta V equals 3.86 times 10 to the negative 6 meters per second squared times 1.555 times 10 to the 7 seconds, which means that delta V is about 60.0 meters per second. And that's how you solve problem 26.